Good morning, Calc fans. How we doing this fine morning? Hope you had a good weekend. We're going to go a little old school today with some video. Your notes have been handed out to you, so we'll go through the lessons. We're going to talk about logarithms today, and some of this should be review for us, or all of it should be review for us. And we've alluded to some logarithm ideas also when we're dealing with our exponential growth and decay problems. But if we take a look at some logarithms, and we can do this, we can go through our calculator and take the log of 1, and we get 0. The log of 10, we get 1. Log of 100, 2. 1,000, 3. 10,000, 4. 100,000, 5. Million, 6. And 10 million, 7. Okay, and what we talked about in calculus is what is the relationship that we have with respect to logarithms and our value that we have here and the value that we come up with. Well, if you remember, this is a log with a base of 10. This here becomes an exponent. And then we have a value here. Okay, so we come up with a value. And if we would take 10 to the 6th power, we would get 1 million. We would get our value of 1 million. So as we go through this property, the basic idea is if I take a to the x power, I can change this to log base b of a is equal to x. Okay, so my base and my base are going to be the same. My value here, here's my value, and this is going to be an exponent. When finding a logarithm of a value, when you hit the log button on the calculator, the solution that comes up is going to be an exponent. So the solution is the exponent of the base of the logarithm. So we have a logarithm here, we have a base, and then we have a value. And as we talked about in pre-calc class, we have a base to an exponent equal to value. This is my log of a base of a value is equal to the exponent. So we'll be able to pull, here's my exponent here. This is my value, and my bases are going to be the same. And once again, this should be review for us, and I let you have a few minutes to write this down. I will also post the video. I will also post the notes too, so if you need to pull something off the notes, that would be fine also. If I'm going too fast, obviously if I'm going too fast right now, you won't be able to hit the pause button. But I'll give you a little bit more time. Once again, if I have a to the x is equal to b, it's a log base a of b is equal to x. Our base and our base of our log, our exponent here is our exponent out here, our value here is our value here. When we have a common log, this is your calculator log. So if we take a look at our calculator, along the left-hand side of your calculator, you have an LOG button there. There's no base to it at all, but that is your common log, which is the log base 10, which is what we were dealing with up top there. Now when dealing with a logarithm, and I want to find log values, we don't have a log base 7 on our calculator. So what we tend to do to be able to solve this problem, let's just put an x there. In the logarithmic form, it's a little bit more difficult to be able to solve because we're not used to logarithms. We don't utilize logarithms a lot. You don't go to the store and use logarithms to be able to figure out how much money you have. You don't buy any clothes using logarithms. You don't go buy some gas or drive your car using logarithms. They're not used very much. So having them in a log form is a little bit more difficult to be able to solve. So let's change it into an exponential form so we can be able to solve this. Well, if I take a look, I have 7 as my base. My exponent is x, and this is equal to 49. Now, this is something that's a little bit more familiar to us. If I take 7 to what power, that's going to equal a value of 49. That is correct. The answer is 2. So my value is, my x value will be a value of 2. If we put an x in here, put an x here, and an x here. What I want you to do is take a few minutes, solve those 3 values, solve those 3 values for the value of x. First, rewrite it as an exponential form, and then see if you can come up with a solution to it then. And you can check your answers with somebody around you. Okay? So rewrite these as an exponent form, solve for the exponent, and then check your answers with somebody around you. All right, we'll start with the easier one down here. The easier one is writing it 2 to the x is equal to the value of 32. So we have to count up on our fingers how many times do I have to multiply 2 by itself. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So x would equal a value of 5. Next one up here, we have 25, log base 25 of 5 is equal to x. Okay, first off, Liam, how did you rewrite this as an exponent or into exponent form? So if we just take a look in the exponent form, Liam, how did you rewrite this into an exponential form? That is correct. If I have 25 to the x, this is equal to a value of 5. Now the question is, what value or what exponent do we have to take 25 to get the value of 5? Well, now that's a thinker a little bit. We have to figure out, well, what do we have to do to 25 to get to 5? Well, hopefully we come up with the idea of we have to take the square root. The square root of 25 is a value of 5. Well, if I take a look at a square root, how do I write that into an exponential form, Dylan? How do I write a square root in an exponential form? Hopefully you remember, and yes, that is correct. X is equal to 1/2. Okay, next one. How would I write that into an exponential form? How do we write that into an exponential form? Ozzy, how would I write this in an exponential form? That's correct. 2 to the x is equal to 1/8. Now we have to remember, how do I deal with 1/8? Well, if I had 2 to the x is equal to 8, Ozzy, what exponent would we have to take 2 to get the value of 8? That's correct. X is equal to 3. But I want 1/8 here. So what do we have to do to get the reciprocal? And think back to our reciprocal properties. That's correct. We have to throw a negative in there. So to get 1/8, my solution is x is equal to negative 1/3. Some properties of logs. If I have two things being multiplied together in logarithms, just like if I have 2 to the 3rd times 2 to the 5th, we can add the exponents to get 2 to the 3 plus 5, which is 2 to the 8th. Well, if I have two things that are being multiplied together, I can add them, log base b of a plus the log base b of x. So we can add those two, give them their own separate logs. And once again, this should be reviewed for us. If I have division, this would be log base b of a minus the log base b of x. Does not matter what base we use, log base b of 1 will always equal a value of 0, because any base to the exponent of 0 will equal 1. What exponent do I need to take b to get b? Well, that would be always a value of 1. So if I have these two are the same, this will be the 1. Log base 5 of 5 is 1. Log base 7 of 7 is equal to 1. Now, the exponent property with respect to logarithms is the most important one probably that we will utilize. If I have a log base b of a to the x, this is going to equal to x times the log base b of a. So we can take our exponent here and throw it out front. And logarithms are also an equality property. If I have two things are equal, then their logarithms, no matter what their base is, will be equal. Whoops. Scribble that out of there. So if I have log base b of a, that will equal log base b of x. So if two things are equal, then their logarithms will be equal. Going to the back, if I have 10 to the x is equal to 20, and I want to solve that problem. If this is an ACT question, option A would be a value of 2. Because people are going to say 10 to the 2th power, 10 to the 2nd power will equal 20. Okay, which is incorrect. But we want to find a value here so we can solve this. Okay, what exponent do I need to take 10 to get 20? Well, that's where we're going to utilize properties to be able to solve this. Okay, the first one is two things are equal, then the logs are going to be equal. So the log of 10 to the x will equal log of 20. Now we're going to use our exponent property. We're going to bring the x out front. So we have this x will come out front. X times the log of 10 is equal to log of 20. Now I did not put a base in there because I'm just going to use the common log here. Well, if this is the common log, that's log base 10 of 10. Well, if these two values are the same, should equal a value of 1. So this should go to a value of 1. So I'm just taking the log of 20. So clickety-clacking through the calculator. Log of 20. We get 1.301. Now if you would take 10 to that power, I'm going to get close to 20, but it's not going to be exact. Log base 7 of 21. Once again, ACT question. There's going to be an option of number 3 there. But in this form, it's tough to be able to deal with. So we can rewrite this as equal to x. Putting it into exponential form, what would this look like in exponential form? Bailey, what would this look like in exponential form? I have log base 7 of 21 is equal to x. Exponentially, that would be, that is correct. 7 to the x power is equal to 21. Now we're in this form here. Let's take the logs of both sides. Go ahead and take the log of both sides. Bring your exponent out front. And solve. Check your answers with somebody around you. So we have x times the log of 7 is equal to log of 21. Divided by log of 7, log of 7. Adam, what do you come up with? That's correct, 1.565. Okay, we have a natural log. If I have log base E is Euler's number here, 2.718 approximately. If I take log base E, this turns into a natural log. And I tend to use natural logs a little bit more than I use logarithms because it's a little bit easier for me to write. But if I have a log base E, I could take the natural log. So if I look at my problem here, let's take ln of both sides. Once again, I like to use natural log a little bit more because we got just one big hump and two little humps there. My exponent, once again, will come out front. So we have 2x times the ln of E is equal to ln of 100. And to solve this, we can divide by 2. And the ln of E, once again, log base E of E. If these two are the same, will equal a value of 1. So this will go to a value of 1 here. So we can divide by 2, divide by 2. So we have natural log of 100 divided by 2. Brandon, what did you come up with over there? That's correct, 2.303. Let's take a look at a quadratic idea. Looks like a quadratic equation. We can go e to the x and e to the x. If I have e to the x times e to the x, once again, properties of exponents. I have x and x, I have a like basis here. If we have a like basis, what do we have to do with the exponents? That's correct. E to the x plus x power, which is e to the 2x power. Combinations of 6 to get in 1 in there would be -3 and +2. Have a quadratic idea that setting both our factors equal to 0. So we have e to the x minus 3 equal to 0, e to the x plus 2 is equal to 0. So solving this, we have e to the x is equal to 3. E to the x is equal to -2. We can take the ln of both sides. The x will come out. Ln of e, once again, will just give us a value of 1. So x is equal to ln of 3, which we can clickety-clack through our calculator. On the right-hand side, we have x ln of e is equal to ln of -2. But if we run that through the calculator, the ln of -2 is not going to work. So this gives us an empty set. So our only solution would be the ln of 3. 1.0986. In your calculator, what I want you to do is I want you to let's solve these down here. We can bring the exponent out front. So we have 5x times the ln of e. Ln of e is a value of 1, so we're just left with 5x. Same thing will happen over here. X plus 3, ln of e. This goes to 1, so we're left with x plus 3. But in your calculator, what I want you to do is I want you to take e to the ln of 5. E to the ln of 5. And then e to the ln of 9. And what we should come up with is what over there, Carmela? Yes, we have a value of 5 here, and we have a value of 9 here. So if we have e to the ln of 3x, following the pattern here, what happens here? The answer should be just 3x. So if we have a base of a log base as an exponent of x, this will also equal a value of x. If we have log base b of b to the x here, this will simplify down to x. So these are two different properties. Once again, I will post the notes. I will post the video here. Your homework is on page 67, 37 to 57, the odds. Should be some logarithm problems in there. Okay, so that will be your homework. So the rest of the time, you got about 20 minutes here in class, 15-20 minutes the rest of the time. Please work on the homework, and I will be back on Tuesday. Adios, have a good day.